was so fun. So what is rock and rolling?
Rock and rolling is the process of taking a rock, either a slab, bloom, or billet, and compressing it through a set of rollers rotating in opposite directions. The large compressive forces plastically deform the metal into a part that has a large surface area to thickness ratio. Can you think of any places that Pitt rock and rolled?
This foil I just bought at Marks to Go was rock and rolled.
These door handles at the Cathedral of Learning were rock and rolled. You can see by the vertical grain structure.
So exactly how does it work?
The solid metal workpiece is plastically deformed by the compressive forces between two constantly spinning rollers. These forces act to reduce the thickness, which changes the geometric shape of the workpiece, but its volume remains essentially the same. Due to the conservation of the volume of the material with the reduction in the thickness, the metal exiting the roll zone will be moving faster than the metal entering the roll zone. The rolls themselves rotate at a constant speed, hence at some point in the roll zone, the surface velocity of the rolls and that of the material are exactly the same. This is termed the no-slip point. Before this point, the rolls are moving faster than the material, and after this point, the material is moving faster than the rolls.
Wow, that sounds perfect.
Let's get real, Jack. There's a lot of problems with rolling that you need to consider.
Since the workpiece rolls between the rollers, friction is a necessary part of the rolling operation. Too much friction can be detrimental for a variety of reasons like heat generation. Lubricants can help control the level of friction between the rollers and the workpiece. In addition, defects like edge cracks, center cracks, and wavy edges are all common with this method of metal manufacturing. Are there different types of rolling? Yes, just like the weather in Pittsburgh, rolling can be done hot or cold. There are advantages and disadvantages to both.
Cold rolling is done at room temperature and has many advantages. Cold forming causes directional grain orientation, which can be controlled to produce desired directional strength properties. Also, work manufactured by cold rolling can be created with more accurate geometric tolerances and a better surface finish. Since low-temperature metal rolling processes do not require the heating of the material, a large amount of energy can be saved and faster production is possible. Another benefit is that the part will be stronger due to work hardening. There are some disadvantages, like the ductility of the metal being limited. This only allows a certain amount of shape change to be produced. In addition, higher forces must be used, which requires higher capacity equipment. Finally, the grains do not recrystallize, which can result in residual stresses.
Hot rolling is done at a temperature above the recrystallization of the metal. At this temperature, the metal has a reduced yield strength, so no strain hardening will occur as the material is plastically deformed. The hot rolling process converts the cast grain structure of the metal into a rock grain structure. Grain boundaries are destroyed and new tougher ones are formed, along with a more uniform grain structure. There are many advantages, like less force needed and a far greater ductility. The much greater ductility allows for massive shape changes that would not be possible in cold worked parts. The disadvantages are poorer surface finish, increased risk of chemical reactions and oxidations, lower dimensional accuracy, and the need to heat parts. The heating of parts reduces tool life, results in a lower productivity and a higher energy requirement than in cold working.
Now that you know what rock and rolling is, it's time for you to rock and roll.